Welcome, everybody. This is our second episode of the REVEL Stupid Simple podcast. I'm here today. Joining me is Kamil, our CTO of REVEL, and we have some really, really great guests today. Surprise, surprise, surprise. Here we got the winners and the runner-ups of the REVEL LycheeAI NVIDIA Isaac Sim Hackathon, which finished last week. We had the judging on Tuesday. We had the live stream announcement on Thursday, which was a lot of fun because the guys actually didn't know who won at all, other than Zakariea, who won the community vote. The public voting ended on Wednesday, so he knew he was coming to take a first from the community. But other than that, you guys had no idea who was going to win. And I remember that you guys, I think Pascalis was like, when he realized that he was going to be, that he's going to take the first place, he was in the background waiting to join the live stream, kind of, what just happened. So that was fun. Yeah. Gentlemen, thank you so much for joining us. We were super, super amazed and just in awe of the talent and the work that you guys put into the hackathon. Thank you so much for learning about it and then being sort of brave enough to sacrifice some time because we know how time consuming this stuff is, to join and put your best foot forward and put yourself out there and say, hey, I'm going to do something. So thank you so much for doing the hackathon, and congratulations to all of you. And of course, one more time, congratulations to all of the other teams that participated. Thank you so much to all of the judges and sponsors and people that help us put this together, including Lychee Mumir, who's running this really cool community in Europe, robotics community. He's an educator. He's running his own YouTube channel where he basically shares sort of the how-tos in terms of Isaac Sim and Groot and NVIDIA Omniverse and so on. And I would actually love to start with the question, has any of you guys been aware of the LycheeAI community prior to the hackathon? And if so, have you used any of the educational videos that he posts on his YouTube channel to, when you maybe ran into some trouble, have you been able to kind of go to his YouTube channel, look up some how-tos and follow a tutorial, kind of step-by-step thing? So I see Zakaria's kind of nodding. Maybe we'll start with you.
Yeah, I knew him before. I think I know him 3-4 months ago when I wanted to look into Isaac Sim, how it works. And I really think that he's doing great educational content, which goes into depth. So it's not like surface tutorials. It's actually answers questions. And for me, it was a lot of help. I had another project that I wanted to do with Isaac. It was a simple reinforcement learning using the SO100 to push a box into a red target. It was part of a uni project. And yeah, that was a lot of help, using the YouTube channel.
Super. He's going to be thrilled to hear that. Who else used some of the tutorials, Sloan?
Yeah. Like Zakariea, I discovered the Lychee channel 2-3 months before the hackathon. It was because I was doing a little project on how doing quadruped robots patrolling into a factory, and it need to detect some waste on the ground and pick it. And so I started watching some of Lychee's video to understand how Isaac Sim work, because it's a really dense software with a lot of things possible. And so I started watching some of video, and in fact, I discovered the hackathon itself by receiving a notification of its announcements on YouTube. And so I saw the video, and so registered to the hackathon the last Sunday before the deadline. So yeah, it's mainly thanks to Lychee and its content that I discovered the hackathon and discovered Isaac Sim.
Incredible. Lukas, what about you guys? I know your partner is missing today you had Jan. But Jan's actually non-technical. Jan is in the VC space. He's the one who usually brings the money to the project. How did you guys get together? It's kind of such an interesting combination.
Yeah, so we've been best friends for a very long time. We've known each other since high school. For the hackathon, I have found out about LycheeAI and the YouTube and Discord community, etc. just about 2 weeks before the hackathon. More like I stumbled upon LycheeAI randomly when I was looking up something for the SO101 arms that I wanted to personally start a project with. I think he started some series with the SO101 and Isaac Sim, and that's how I found out about LycheeAI. And then, I don't know, 1 or 2 weeks later, maybe the hackathon announcement dropped on LinkedIn, I think. That's where we saw it. And Jan and I actually saw it like independently from each other. And we thought, yeah, let's do this project together. Let's reconnect on this project. And yeah, it was a great time for us.
Amazing. So did you use any of the tutorials? Because you guys picked a humanoid as the robot of choice.
Yeah.
And you guys did Groot training, and you even set up your project with the cloud. You needed some cloud compute. You started on H100s from the NVIDIA BREF cloud, and then you actually needed to speed up the process because the deadline was approaching. So you guys switched to the H200.
Right, yeah.
So did you watch any video tutorials on that, or did you kind of had experience with that prior and already knew kind of what to do? And also, if you can kind of unpack the complexity of that, because, as you know, we've talked about it briefly with you guys, like what REVEL is working on. But if you can kind of talk about the pains of what it's like now to get your project into the cloud and get compute.
Yeah, for sure. So I've had a lot of experience in the past with cloud computing, setting up clusters to train models on the clusters. But it was actually my first time also using Groot and a vision language action model like Groot for fine tuning. Of course, I've used LLMs and VLMs a lot in the past, but just for inference when I've used them. But yeah, now during the hackathon, I kind of wanted to give Jan like a full round trip, showing him everything that's going on in the domain of robotics right now. And that's why we decided, well, let's go all in. Let's do a humanoid. Let's do vision language action models for like optimal control stuff, etc. So
was there real quick, was there an debate between the UniTree G1, or did you guys were pretty set on that robot and its open source file, or did you look into other humanoids as well?
We started actually with what's the name again? Fourier Intelligence GR1, I think. That's the name of the other one. That's the one that we started with, actually. I'm not 100% sure why we switched exactly. But at some point, we decided to go with the UniTree G1. And we stick with it. And actually, so since you mentioned the cloud computing, that was a lot of a mess, to be honest, because we started with trying to fine tune Groot locally. But of course, we didn't have a big enough GPU to get it on the GPU at full. So we had to do low rank adaptation fine tuning, and it didn't work out as we expected. So we had to find a way to train it on a bigger GPU. That's why we went to BREF, and was a lot of a hassle setting that up. So just to give you a brief intro on how I did it then at the end, I've used Docker actually to put all of the Isaac Groot stuff into Docker and then putting that on BREF. Spent some time trying to figure out how to set up the container optimally so I don't have to load up the 50 gigabytes container always from my PC locally into the cloud. So that took a bit of time, and then also trying to figure out how to get the data on the cloud computer. That was also a bit of actually, I guess it's not the intended way, but I did the fastest and hacky way. So I put all of the data at the end also inside a Docker container, then just pushed it onto GitLab Docker registry, and then I could easily pull it from there.
So you were legit hacking throughout the hackathon, just
Right.
hacking away and hacking everything,
Right,
everything. Do you remember how big the container ended up being?
So the Isaac Groot container actually was 50 gigabytes because I completely built it and built all of the libraries in that container. So I didn't have to build it from scratch every time I booted up the BREF instances. Was mainly because, well, we didn't have so much time to always let it build. And it was also, I mean, every hour costs on BREF. So you have to be quick as well. And downloading the 50 gigabytes was faster than I think it took 1 hour to build.
Could you give me an estimate on the total time that you think you spent setting up the compute? Like from when you're like, okay, we're going to need to run in cloud. What would you say was sort of the time that it took?
So
are we talking a few hours? Are we talking a few days?
Well, I would say in days. On Sunday, on Friday was the deadline for the hackathon, right? Friday, yeah. So on Sunday, we decided, well, low rank adaptation wasn't going to cut it, so we had to go on BREF. So on Monday morning, I started setting up BREF, setting up all of the data sets with the containers, etc. So that took, I guess, 1 day. So first training on BREF, then I started on Tuesday, I think. Then it was only like Tuesday, Wednesday, Thursday that we had for training. Of course, I mean, you never get it right on first tries. I had to, I don't know, do this same process 2 or 3 times, and always it takes some time to set up the BREF instance. So, I mean, once I had the Docker container, it was more like in the range of 1 or 2 hours to get everything set up and run the training. But for first training, it was more than 1 day, I would say, to set it up.
Would come quite handy in that situation. Pascalis, have you had any sort of interaction with the LycheeAI? I think you were part of his previous tournament.
That's right. Yeah.
Yeah.
I also participated in the previous project. Yeah.
Excellent. And so how, in terms of the content that he's producing, have you ever kind of delved into it to get on some of the things that you're working on?
Yeah. So actually, like, Lychee was for me like a great motivation to get started with Omniverse. His tutorials are great and a great start. He even covers how to install everything and set everything up into detail, which I think is well received in the community. One of his most viewed videos are actually how to set Isaac Sim up. So also did a video with him about my previous project. He hasn't reached out to me yet about this project. Maybe can also do some feature video where we go into detail, because I think
I'm sure I'm sure that's on the table. There is so much that happened around the hackathon on the back end of everything, gentlemen. It's like we're still kind of catching up with messages and emails and all the things.
I'm actually surprised how quick you were with everything. I think the deadline was on Friday, and by next week we had already the NVIDIA call. You had done all the grading and set up the podium, the winners, the judges. So huge kudos to you. That was really amazing. I didn't expect it to be like that quick.
Well, thank you. I really appreciate it. I didn't sleep for a month, but it worked out.
It was a fun weekend for sure.
Okay, and let's talk about a little bit your project then. Obviously, you're the winner, so congratulations once again.
Thank you.
Funny enough that you mentioned the videos and sort of the ease of some of the things that Momir puts out there. The other day, actually, though, I came across a video of his, and we kind of both laughed at it at the end because, hey, it was titled something funny. It was kind of like, hey, look how super easy it is to like get started with NVIDIA Isaac Sim. And then the video starts. I mean, the first thing goes like, okay, you have to go to here, this part of the website, then you open this container, then you scroll down here, you find this extension, you first need to upload this driver, then you unzip this file, then you transfer it into this container, and then you can start running the installation. During the installation, it's going to ask you to do A, B, C, and I was like, there's nothing simple about this. So there's absolutely nothing simple about this. And I sent to him, I was like, hey, the title of the video doesn't quite match the first 60 seconds of where the video goes, but it was beautifully done, and he's so patient and kind of calm in the explanation. So big shout out to Momir one more time. We're putting up another one for you guys and for everyone who wants to participate in November. I think we're going to be opening the registration somewhere in the end of October. And as we mentioned on the NVIDIA live stream, our goal is to sort of 10x everything, 10x the prize pool, 10x the number of participants total. I think we had like 300 plus, so that would mean like 3,000 people. So the stakes are going to be hopefully also 10x and higher, and reach more robotics clubs, more universities, more researchers, more PhDs. And for us, this is great, guys. We're basically building in public and collecting data on what's working and what's not working in robotics, having these kind of conversation with you guys. And then we're building REVEL really for people like you that want to do cool things with robots, that want to train robots and do some kind of cool things. Lukas, real quick, going back to what you were talking about, do you remember, this is something that when I talk to a few people here and there, they get quite shocked how small the models actually for robotics, like the controlling locomotion of a humanoid is something like 1.5 million parameters. And people are really shocked, like, wow, it's like that small of a model that controls the sort of, the basic locomotion, walking and whatnot. Do you remember when you guys finished training the model, and what was the weight of the model when you finished?
You mean the size of the weights? Like in the file that we ended up with, or
Do you remember how big it ended up being?
like on the GPU, it's about like 10 gigabytes, and I think the file is between 7 or 8, if I'm not mistaken. But yeah.
Do you know how many parameters of a model?
Oh, you mean how many billion parameters?
The model.
Or?
Yeah.
Well, I didn't change the
Million
number
or
of
billion?
parameters, so it's 1.5 billion.
Got
I think,
it.
right? Yeah.
Okay. All right. Cool. Olsson, a hospital. We want to talk about quickly how that came about. You guys all registered for the hackathon. You had no idea what assets you're going to be choosing from. I think we put about 30 assets into the library from REVEL, but you had no idea. So you were kind of like, okay, I'd like to build something like this in the registration form, but I don't know which assets will be available. The rules were pretty straightforward. You had to use the asset in the pick and place motion of the robot. So let's talk about a little bit like when you open up the library and realize what assets are in there. How did you kind of start navigating? What could I build?
Well, in fact, to be totally honest, I did not have any idea of what I am going to build, and I just saw the different assets. Like I saw the tray, and I was okay. I want to do something which navigate with the tray, and so I was thinking about doing a bit like the packing panther with an humanoids. But in fact, I was thinking that I won't have enough time to train the locomotion and also the manipulation of objects, because I know from experience from the work that it's not really easy, and most of the time the locomotion is still a bit jerky, so make move the tray so object can fall from the tray. I was thinking using a mobile robot with a autonomic base, like no legs, just navigating on the ground. And then I saw the shelf and some of assets which can be picked from a shelf. And so I think like, okay, I can do maybe something where a robot takes something from a shelf and then put it on the tray, and then the robot which has the tray move something. But I know from my experience that I cannot finish any project if I do not have a concrete context around it. And so here came the idea of doing an hospital when I was navigating into the different assets that provide also is Axim. They are an environment called hospital. And so I directly think of, okay, maybe I can add a language where patients are in their room, can like speak into their microphone to ask to the system something. And as one of the judgment criteria was the usefulness of the app, I was okay. I know that nurse and doctor are always doing a lot of things. There are a lot of things to do. But we lack of some nurse in certain place, so it could be really important and impactful to do something like this, even in the real world. So I was okay. It could be great to make something to make a simulation of the system. And so here was the idea. It took me like maybe 1 or 2 days to really think how I will doing the system, or I will make all everything connected together. And then I start work directly on it and finish on time. Not entirely, but I at least respect the deadline.
Is there somebody in your family or someone that you're close to that you've had these conversations with about actually, because it's so relevant, right? Like there really is a shortage of nurses worldwide. Yeah. This is a pretty common problem in America, in Europe, and other countries as well, of course. So, having them focus on the human interaction with the patient and having the doctors tend to the patients as well, while automating some of these kind of very labor and time consuming tasks through robots, was totally makes sense. I'm kind of curious to see if was there somebody in family or friend that, like you picked up on this, like, hey, like, friend is a nurse, or how did you learn about sort of that problem itself?
Yeah, in fact, I have a lot of my friends which are going to be doctor or nurse, doing some study for that, and they are at a point where they are like working 40 hours a week, and they are just doing things like that. Like this, it's called like an internship. They are interns, and they are working on a hospital and just help patient, bringing them bring them what they ask for. So they are not really doctors, nurse, and they are like working non-stop on this. They are sometimes even staying the night to I don't know the English term, to verify that everything is good. It's good maybe. It's like they need to sleep on the inside the hospital, stay here. And if there are a problem with a patient or a patient asks for something, they have to get up and bring them what the patient asks. So I like chatting with them. I understand that this is really problematic because it's a really hard task. They are sleeping here. It's break a bit like the family life, sorry. They don't get home after the work. Yeah, just chatting with them, I understand that it could be something really problematic. And if myself I had to do this, I will probably be a bit sad of working like this. But it's important, in fact, for patients, for everyone. They are doing this sacrifice for helping the society. So I think where robotics could be the more impactful is in work like this, where people are doing a lot of important things. Really not, how we can say, really not demanding, but it's time consuming. So robotics can do this really simply. So yeah, that's why and how I came to the idea to doing this.
Thank you, and congratulations again on the success of what you built. When I was looking into the research of this topic, I was shocked that I think it's about 70% of the time the nurse is called to the patient. It is sort of, can I have some crushed ice? Can I have an ice pack? Can I have an extra pillow? Can I have an extra blanket? Can I get some book, please? Could you, this or that? It's sort of this, take this away, take this away, which is sort of, then when somebody has like an accident and they need to be cleaned or bathed, washed, or taken for IV or this or that, that's where you really want to have the human, but like, hey, I need an extra ice pack. Can I have some extra water or this? This is a fantastic opportunity for usefulness of robots. I think we have to make that hospital robot still kind of appealing visually and really friendly looking, inviting, this trusting, especially for elderly patients. So they would feel comfortable and not sort of scared that there is a mechanical unit roaming around. And so maybe programming some voice and, some crack a joke, when the robot enters to lighten up the mood or something, can read the emotion of the humans, because people in hospital are usually at their most vulnerable place in life or positions. Yeah, great. Really, really, really great job. Congratulations. And we'll talk more, but I love how you put everything together. I was really waiting to see if anybody was going to pick the tray from IKEA, the typical cafeteria tray. Actually, you and Lukas and Jan, the Packing Panthers, also picked the tray with their butler. And I think your butler in the setting you guys actually picked as well was also a hospital. I think you guys also, Lukas had
Yeah, we picked the hospital as one type of application where it could be placed in. Yeah.
Okay, we got
I have one question.
Yeah, go ahead.
You chose the infamous claw machine, right? Which we've all experienced when we were little, maybe when we were adults too. What made you choose the claw machine? Have you had a lot of fun times with it when you were younger?
Sure. Spent a lot of money on claw machines. Lost a lot of money there. I think only 1-2 times. Some fluffy toy. Actually, going back to Brian's question, previously you didn't show us the assets, but you made us also describe our project. So that's why I had the bark and bite idea, and wanted to have some robot to give my dogs treats. But then when I saw the assets, I thought, this is going to be hard with the assets provided. So there were no treats in there. That's why I thought, maybe just put them all in one place and try to grab them. And then gradually this idea came to life. So I started with a claw, and then I thought, okay, maybe how far can I push the limits of Omniverse of Isaac Sim? And turns out pretty far. So, the software is pretty good in simulating reality, but you have to tweak a lot to get it right.
You did a good job.
Thanks, Gabriel.
This is it. The saying about the presentation was just so on point with your presentation. It was, it was like a little movie to watch. And I think we had a lot of technical judges on the team, but we also had a lot of people who really needed the explanation throughout the process. And as soon as the claw machine showed up, Lukas, which was one of our judges, maybe you guys are familiar, he's a pretty big voice in terms of LinkedIn and robotics. The first thing that popped up as soon as your video started to play was this image from the Toy Story movie with all the little toys on the bottom, and they're looking at the claw. If you guys remember the Toy Story movie, and they're like, he's here to choose, and it was kind of like that. And everybody just went immediately back to their childhood, like, yeah, Toy Story and Colin Arcade and stuff. So it was really great. I actually want to ask a technical question that we were talking about with Kamil, and that was the rope and the simulating of the rope, which is basically the formable object. Can you talk about a little bit, because you went one direction, you said didn't quite work well, and then you went a different direction. Can you talk about that a little bit?
So the rope, so I saw, like, when I researched it, I found a community post on the Omniverse community where someone was showing how to create a rope. And what he basically did was a lot of little capsule rigid bodies and then attached them one to another. So I created like a little helper script that did this with a prim-based approach. So in prims, you have them, they're selectable in Omniverse. You can have like they're individual and you can select them. But there's also something called the point instancer, where you lose this ability to select them via the UI. But I'm not like 100% sure how it works. But basically, it's much better in performance. So if you have like a lot of objects and a lot of physics objects, the best way, I think, or one way to go would be to use this point instancer approach. But then I had some other components like the winch or the claw, and I would want them to be prim-based, and I wasn't quite able to attach both, like the point instance approach with a prim-based approach. So everything was just prims and also just rigid bodies, but a lot of rigid bodies actually. So that's why you get the feeling that's a deformable body. But it's basically, I think, 50 or 60 individual rigid bodies.
So the rope was more kind of representation, almost like a chain?
Yeah,
of
yeah,
rigid
it's basically
bodies,
a chain.
essentially?
Yeah.
Do you remember how small were the each link of the chain? Like how to get the result in sort of simulating the physics of or the appearance of rope? Do you remember like how many?
I don't know like the dimensions, but you can somewhat see it in the video where I showcased how I pulled it through the torus, through the small hole to retract it. There you can see.
Yeah, it looked very small.
When you look
closely, like maybe
a
it looked very small.
So that's
like
why I had like 50
or
60, but in total it was only like 1 meter of rope. So yeah, basically a few centimeters. I don't know how much it is in US units. I don't know, some inches.
That's okay. We can do 1 inch is 2.54 centimeters.
Yeah. Okay. A couple of inches.
So roughly an inch.
Roughly an inch.
Little, one of those cocktail sausages from. Anyways,
basically.
Zakariea, you are the winner of the community, and your selection was actually the most common selection, but we really felt like you went sort of next level with the chess. Can you talk about how did you hear about the hackathon? Why did you decide to join? And when you didn't know what assets are going to be put in front of you, when you did open up the asset library, how did you decide which direction you wanted to go, and kind of what challenges you faced throughout the process?
Yeah, of course. I heard from the hackathon through LycheeAI, like through his YouTube channel. Same like the other guys here, I was just following him and I saw the video and I instantly knew I want to participate. And actually, in the beginning, I wanted to do something like WALL-E. Like, I loved this movie. I wanted to have like a mobile robot that goes around, picks up trash, and like can kind of sort it. But
I love that movie too, by the way. I hear you. It's one of the best.
But there was like no trash in the assets, so I ended up doing something else. And I saw the chess asset, and I knew like most people are gonna pick it. But I thought, okay, it looks fun. Like, let's see what we can do with that. And yeah, that's the reasoning behind it. My goal would be like to transfer this policy also into the real world, because that could be really fun. Like the S100 arm like costs only 100 euros. So it could be pretty affordable to just attach it to a chessboard, and it could like automatically put the chess pieces into the initial position for you. Or like you could use it that it trains you to learn new openings. It forces you to do the correct opening. And if you fail, it would just start from the beginning. Like I think there are like a lot of ideas. You could also like build two of them, and so you can play with your friends physically, but still like from a far distance. So you don't have to go on your mobile app and press on those 2D chess pieces. You could do it in the real world. So there are like a lot of applications, and I think it's really fun.
I have a
Yeah, that would be
question.
great.
I
Go
have a
ahead,
question
Len.
on yeah, sorry, question on what you did. In fact, because I know that when you are trying to make a policy to take an object somewhere and put it somewhere else, it's in fact very hard to design a reward function to this. So did you use some demonstration or imitation learning, or directly you craft a reward from AI?
Yeah, like also fine-tuned VLA model, like the
Okay.
packaging patterns. So I
Okay.
think that's the easiest way. Initially, I tried to have as many random positions as possible, but I could say, like as Lukas, after the initial deploying the policy, it didn't work at all. And I thought, okay, I'm gonna like for the hackathon, I'm just gonna use 2 initial positions. The first one was super easy, like move the pawn to 2 positions further away. Like that's wasn't a big problem. But yeah, like normally I think you would need way more data samples. I only had 50 at the end to actually learn all the positions or to learn how to move one chess piece to any arbitrary position.
Kamil, you had a question?
Yeah, that would be great having 2 people play chess, maybe voice controlled, eating food. They don't have to do anything. They just say where the arms move. That'd be great. My question is, you guys saw each other's submission, and we're going to post the top 10 on our website, on the Hackathon website. So later when it's up there, you guys can go check out the other ones and kind of see how you guys compare. How do you guys see the other submissions? So you 4, right? Do you see that you guys are on kind of the same technical difficulty level, or did you learn something from the other guys that placed in top 3 or the community award?
Like if I can begin, I think the difficulties are really completely different. I feel like Pascalis like completely used the Isaac sim to like normally it only works with rigid bodies, but like the way he uses it, he could like replicate a chain. So I think that's really awesome. And me personally, I rather like train the model and set up the environment. So I think that's kind of different.
Yeah, I totally agree with Zakariea. So I had no robot, no machine learning, no model that I trained. I focused mainly or nerded out on physics and how far I can push that. But yeah, there was some, like, for example, I also liked Zakaria's post in the community, because you shared the community videos beforehand, and also the one from Dan where he basically threw an object. So I think this was also like a cool approach. And from the Pro League, something that I'm also interested in and I would like to explore is this teleoperation as a baseline for imitation learning. So something that Lukas did, and also there was also another project where he had like a real robot, a real sew arm, and used the embodiment of a different robot to teleoperate it in simulation and to basically use like reality for some baseline that you can use later on for imitation learning. I think those projects for me are very interesting, and I see a lot of potential in this.
And if you guys don't have anything else to add, I have one more question. So most of the submissions came in at about an hour or 2 before the deadline on Friday. Were you guys one of those submissions, or did you guys submit ahead of time?
I submitted, I think, 1 hour before the deadline, or half an hour before the deadline. So yeah, it's only 2 weeks. He only gives us 2 weeks, and I have a day job, so I only have the weekends to work on the project, and a little bit on Friday putting everything together. So yeah, I was one of the late entries, but on time though. On time. No, I didn't go overtime. Yeah.
And if you could estimate, what was the total, just guess, what was the total amount of work that you actually put into the project in hours?
Yeah, that's a really good question. I'm curious myself.
It's hard to do. 3 days that I worked like very hard on it, so couple of hours. I think I'm not sure about it, because I started like in small increments. You know, I first did the claw and some physics testing there, and my day job also involves Omniverse, so that's why it's hard to, you know, like what is for the job and what is for the hackathon, because
it all blurs
as
together.
you like basically, so yeah, couple of days and a couple of hours for those days.
I just realized Lukas cannot hear me. Brian, if you could ask him, how long did it take them?
Lukas, I'm going back to my translation role here. How long did it take the Panthers to work on? Like, how many hours total would you say the team spent on the project?
So I counted my hours actually. Well, I stopped counting beyond 100 hours that I put into the project.
Wow.
And I think Jan maybe
Okay.
another day. So yeah, definitely more than 100 hours together.
A lot. Okay. And Lone?
I think I am maybe more around 40 hours. Like as Pascalis, with my day job, I mostly work on the 2 weekends that we had. So it was like to 11 p.m. and doing some break to lunch, going to gym and play a bit. But it was mostly all the weekend long. So yeah, I think and some nights too. I in fact, as the deadline was Friday and I was scared to not have finished the whole video, I just like asked my job to being in vacation right Friday morning. So I just like finished the video here and submit at 12 a.m. So yeah, I think definitely less than Lukas, 2 times less, I think, 40 hours.
No, sorry, go ahead. There was a previous question from Kamil as well, and were you one of the last minute submitters or because we actually received majority of the submissions like a half an hour before the submission deadline. And we had so many participants, so many registered teams. And like 3 hours before the deadline, I think we had 9 submissions. So we were like, wow, the fall off. And then just, just a crazy amount of submission came in within the hour and a half an hour of the submission deadline. Were you guys one of those teams?
Yeah, actually, so we read on Discord later that the deadline actually got like pushed, right? For 5 more hours.
Yeah, we had it. So one thing that we, please excuse us, and I kind of wanted to talk about that just briefly. This was our first ever hackathon as REVEL, right? Like we're a startup building a product, a company, talking to investors, and we have our own team and everything going on. And we basically are kind of went with the hackathons as to meet our potential customers, address the issues in the market, address the issues and the problems and so on. And we'll get to talk about that. But this was our first hackathon. And one of the mistakes we've made was sort of people not understanding the time zones, because we had registered people from all over the world. And we had some people messaging us like, oh, well, yeah, I thought it was 8 o'clock, like my time, not, they were like, what's Europe, Central European time, or like American time, PD. So what we did was we did basically like an extension to even out the 8 o'clock for everyone. It to be in 8 o'clock. It was 8 o'clock in Europe. It was 8 o'clock in, New Zealand. It was 8 o'clock in California. So there was about a 10 or 12 hour extension to the submissions, because people were like, hey, I'm running home from work. I want to submit the project. Like, I thought it was my 8 p.m. So next time we got to be more clear on the centralized time for everyone and for submissions and stuff. So you guys submitted earlier or?
Yeah, so no, on our time, actually, it was 1 minute before 8 p.m. So it was last minute submission.
So close. I wanted to comment real quick on the SO100 arms. It's one of those things that, like, if you skip Starbucks for a week, you can just get one of these robots. It's an incredible kind of a little tool for like I said, you could skip Starbucks for a week and then you can just have a pick and place robot on your desk, which is great for the sim to real transfer. I wanted to quickly ask you guys, feel free to jump in and answer, but what is your guys' level of experience with the transfer of sim to real? And if you could kind of speak about the failure between sim to real, like, if you do a simulation, how often it translates well to real and so on.
Yeah, maybe I can start. So I did a sim to real project almost 4 years ago, I think. And it was not with Isaac and not with NVIDIA, but with the UniTree engine, in fact. So I trained a robot in the UniTree engine. And this is why I have some experience with modeling and simulating stuff. And for me, so the hardest gap was actually the visuals. So the robot I used was a small, like a Roomba, like it was a small wheeled robot, and it had a camera. So simulating the physics, the rigid bodies, was also relevant, but not so relevant as the actual visuals. So I had to match the visuals in simulation like really closely to reality to be able to transfer it into reality.
Super cool. Anybody has experience with sim to real, or most of the simulation? thus far?
I also did it with Unity, like my last project at university. And it didn't really work out that good. Like, yeah, we didn't do enough domain randomization, but I think that's really important. And it was just a matter of time. We couldn't finish the project. But yeah.
When you mentioned the WALL-E movie, if you guys seen the movie, which it's really, really lovely, but it made me think of the when we were talking about your project, Zakariea, about the chess playing, and Kamil said like, well, I could be having a sandwich and play with my friend, and the robots will be moving to pieces. In the end of your video, the arm went quite haywire and crazy and started to tossing the figurines all over the place, right? So it'd be kind of interesting if you're just eating a sandwich and the SO100 arm or whatever robotics arm just starts throwing chess pieces at you, like you get hit. And also to the reference of the WALL-E movie, I don't know if you guys remember, but in the WALL-E movie, the humans left the Earth, it's a pile of basically trash, and then they're on this boat, right, where they're like these crazy chairs where they basically really don't do anything. So I hope that the demonstrations of playing chess was wonderful, but I hope that we'll stay with playing chess. Chess games stay with playing against a human. The effort of moving the chess pieces not that big. In terms of like across the ocean playing with someone and kind of have this robotic control, like I think that's really really exciting. In the last part of this podcast, guys, that we're going to put out there, would love to talking about a little bit about the current pain points of robotics training, simulation. I think we'll focus on the simulation. It's one of the core pillars that we're solving at REVEL, which is data and training. As you know, we're on the mission to make robotics training stupid simple. We even named the podcast after this mission. So this podcast is called Stupid Simple. And what that means for us, at least in our vision of where we see this, similar to where the building of apps and web applications and so on has head out with, products like Bolt, a product like Lovable, where you can have founders, even not so technical founders, build prototypes and deploy demonstrations to a team is pretty awesome. They call it vibe coding, so we're calling it vibe training. Can you guys kind of talk about a little bit the difficulties, the biggest pain points and challenges in terms of like the software stack? And one of the things that we see is the software is built by incredibly smart PhD level engineers and shows it's got a lot of power, but therefore it's lacking certain user friendliness. Can you guys talk about like, hey, the biggest pain points, where would you like to see progress made, and knowing what you know about REVEL and what we're working on, if you could give us some pointers of what would you love to see solved. We briefly talked about the compute, so maybe you can mention that, but is there any other things, and would love to hear from you guys. Feel free to jump in.
Sure, I can start. You guys can join later. For me, it's also like, as you said, the software is great. I mean, you have so many possibilities of configuration. There's so many things to do with Omniverse, with IDEXSIM, and due to its fact that you can like build custom kit extensions to your needs, either Python based or C++. This is awesome. So it's just like a really awesome tool. But then again, as you said, it's like maybe a bit overwhelming, and getting started is quite hard. So that's why I'm like super grateful to people like Muammar, who did a great job with all the content he provided to get people started in Omniverse. And you can basically like build even on top of that, as you mentioned, Brian. So to maybe streamline certain workflows, to automate them, to make them a bit easier or more user friendly. I think this would be great and would help like a lot of people getting started with Omniverse and making, as you said, developing robots stupid simple. I think there's a lot of potential to go this way. Give the mic to Lorne.
Yeah. But it's in fact, I never really started training for a policy in Exim or Isaac Lab. I was more in the model-based side of the robotics, like a question to solve directly and generate the trajectory. That's why I start directly with it during the hackathon. But it's sure that data is a key point is for the robotics training. We solve this with LLMs, where we need billions and trillions, in fact, of data. Quality data. But for robotics, even if there are some research effort to bring the more data for robotics movement, it's not at all at the same level as text pure. And so being able to augment using simulations the number of trajectory like Omniverse, Groot, which can automatically increase the number of data using fabrics, randomization, things like this, and having a society capable of bringing really qualitative assets, which looks like real life, as you provide with REVEL, for example. It could really help policy to converge more efficiently to a behavior that will work in simulation, but also in real world, because the quality of the assets looks in simulation looks like the real world. So it could bring, I think, a real impactful sim to real transfer without needing a lot of randomization and things like this. But I did not experience it myself. In fact, like maybe Zakariea did with the SRAM to train the chess. He probably rapidly see that it needs a lot of data to make a model like this converge to a simple task of making the play a piece somewhere. Sorry, I lose my word, somewhere to somewhere else. And even for a simple task like this, you need a lot of demonstration, a lot of randomization, and it only works to be transferred in the real world if the chess that he used in simulation it looks like the same but in the real world. So providing some assets really with a very high quality is in fact, I think, the best way to limit the sim to real gap. But as I said, I not really experienced it myself.
Great. I see Lukas has joined us back. We can't see your video, but Lukas, are you with us? We can hear you, maybe?
I can hear you, yeah. Don't know why my video doesn't allow me to turn it on again. Sorry, I think my connection dropped or something.
Yeah. Maybe you can try to see if you can hop off and hop back in if they're going to fix the camera issue that we had before. We're currently talking about sort of the pain points of the robotics training and kind of going in a circle. Zakariea, you want to hop in there and tell? So yeah, I'd love to hear from you. Where do you see sort of the biggest pain points of robotics training that you've experienced, and then where would you love to see some improvement?
Yeah, like definitely currently Groot Mimic is already like just from the capabilities sounds really great. You can change the lighting, the texture and so on. But maybe correct me if I'm wrong, but currently there's also something missing like an asset randomization. So I'm pretty sure like, okay, maybe I made the sim to real work for this chess asset, but I'm pretty sure it wouldn't work for another one where the pieces look a little bit different. So I think something like this is currently missing, or like what I've seen. I don't know. You build a sandwich maker environment, and then the patties look. You have like one asset for your patties, but would be kind of missing that you have some variation in the assets. So maybe that's something REVEL could definitely look into, or you're already building something like this, because this would be really
randomization of similar objects, identification, and absolutely is definitely one of the core things that we're looking at, because, and also like really wanting to have a library, very strong library of real world assets, meaning things that robots will most likely come in contact with. We actually have a whole agentic system that's doing sort of a research and looking at the next 3 months, 6 months, 12 months, 2 years of what are most likely objects that would be useful in manufacturing, warehousing, hospitals, and so on. And that would basically, that we need to have in the library, and we need to have with the domain randomization. Hey, Lukas, there you are. The domain randomization that you were just talking about, Zakariea, and the variety, and also have the models be able to recognize, no, this is still a patty. It's just got squished in the transfer a little bit, but still a burger patty. This is still a slice of cheese. This is still a piece of lettuce, and being able to still identify the objects correctly. I think that is definitely a very, very good point, and something that's super needed. We're working on it hard. So that's a great point. Lukas, we were talking about current challenges in robotics training. Where are the biggest pain points, and kind of what you would love to see improved?
Yeah, so I've heard a few keywords here and there that you've dropped already. So from my perspective, well, as I've explained before, I think what was really a mess is trying to get everything training properly with the data and the models, etc., on some cloud computing. So that's really an avenue that I see a lot of potential for.
So taking away the complexity of setting up the training to where you could either take the file or just be logged in through our platform, drag and drop the file, get a pre-calculated cost of the compute, so you know what it's going to cost, how long it's going to take, and then just kind of one-click pay in terms of tokens that you've purchased or directly debited or something like that. Yeah, we hear that a lot, and it's probably the first feature we're going to go out with, actually. And if we can, we'll try to make it happen for the Hackathon 2.0. But if not for the 2.0, we'll definitely launch it in the 3.0, where, you know, we would have the training platform live along the side of some of the assets and allow people to say, okay, I've built now my project, drag and drop the file, one click, run compute if needed. Okay, that's really, really great. Is there something that you guys see? This is a bit of a bet and a bit of a future. We see a huge potential. At REVEL, we're looking at the generative world, the generative assets in terms of, you know, simulating generatively physics, center of mass, gravity, and so on, randomization. How do you guys feel about the intersect of physics engine and generative worlds? Have you paid much attention to it? And do you, I guess the question really is, we see that ultimately, ideally, we would see the robots sort of learn from imitation just by watching the sort of the way that humans learn. You can watch a tutorial, like if you're watching Momir's tutorial on doing something. Ideally, we would like to, you know, one of the core features we're developing on the REVEL training platform. And sorry, I'm circling around the name. We just haven't announced it publicly yet, but you know, but it's coming. You know, one thing that we'd love to get to is show the robot these synthetic training, sort of training curriculum from text and videos with simulated physics, and label that correctly, all the trajectories and so on, to collect as many tokens as possible from this training curriculum and then train a new model on that particular skill. You can, you know, something as simple as like, teach this robot how to use a hammer, teach this robot how to do ABC or whatever. Have you guys came across any research or any, you know, I've been seeing a lot of different angles on this on LinkedIn and all over the place, and unis as well as research papers and so on. What is your guys' take on the future of learning? Do you guys betting on physics and simulation engine like Isaac Sim, or do you think that we're going to eventually get to the point where robots can learn purely off of imitation, and even kind of getting away from the teleop imitation learning, but really just showing the robot billions or hundreds or millions of generative videos with that particular asset and that particular robot from multi-angle kind of, you know, viewport, and just collecting data on all of that data that we're showing to the robot being generic. This is something that we, at a core of REVEL, at the training platform, we're making a huge bet on. So I'd love to kind of hear your guys' take, where you think that technology is and where it's going, or if you came across anything in that domain.
I think that the main difficulty of the approach you present, like doing just imitation learning by watching from robots, the main difficulty will be to transfer the control. Like when you're doing something like this with a robot, like imitation learning, you are basically mapping each possible state of the observation space to an action space, to an action. So like for each joint of the arm, you will control it, like sending the position angle if you control it in positions. And so each robot has a different configuration, like different joint, different size of body linked to joint. So being able to just transfer all data from a robot to another, just like this, I think it could be really, really difficult to do this properly, because it will need an adapter, something that it can translate from the
like
original.
A converter.
Yeah. That it can
so calculating like having the math figure out from the source video, from the training imitation video, labeling all of the distances, you know, in terms of movement, and then recalculating and adapting that into the different degrees of freedom and capabilities of variety of robots. Is that kind of what you're thinking? Like that you have so many varieties of robot that it would be quite complex to convert.
Yeah, because it's not like there are like a lot of unique robots with a unique configuration. So being capable of building this transfer model or traductor if we want. It's more complicated, and in fact, I think that simulation could bring a lot of quality data, like as I already said this, but if you are in capacity to simulate something really close to the real world, like physics, like quality of data, which looks like in the real life, it could really facilitate all the training, the first pre-training part. And then when you have all this all done, you can just transfer to your robots in real life by doing a bit of deliberation, or maybe not at all if you have enough data and simulation that work correctly. So I think the easiest path is maybe more turning with a simulation, with a generation capability of object, diffusion, randomization, things like this. But it's do not mean that the second option, like being able to transfer everything to another robot, won't ever happen. I think it could work, but I think the path is more complex than the first one. So at short term, maybe the first one with pop-off, with really good things, with really good movement, is like all current robotics society are working. Like they are doing some imitation learning on humans' movement, and then using simulation to randomize a mass of robots, frictions, physics, objects, and then we are seeing really great demonstrations of really high quality movement from robots, or really high quality manipulation. I think about Figure, DeepMind, Google. So I think the easiest path is the first one, but it doesn't mean that the second won't ever work.
Can I maybe add on that? Or like it's rather a question, but I don't know how you guys see it. Couldn't be also possible that we completely skip the simulation part in the future? Because you can like just give a lot of people the Apple Vision Pro. You can create a training environment in the real world and just let other people teleoperate using the Apple Vision Pro, like for, I don't know, 10 euros an hour. And they could be collecting like a lot of data, because then you would skip the sim to real problem.
I think something similar happened in the early development of the generative models, right? Where there was some cheaper labor hired around the world that basically was labeling millions and millions of pictures every day.
But it's really costly. It's really time consuming to do this. So if you have different robots and you need to collect data to control it, you will need like 500 of hours of teleoperation data that can take 3 months of all day long teleoperating. So simulation, in fact, brings that we do not need any long teleoperation sessions. But I think you point a good point, like
it's a multimodal approach.
Yeah.
It will need like a little bit of everything. So you can have like a few hours of simulation, simulating years, and maybe the quality is not so good as in reality. But then again, it could help to give it a little bit of a boost, and then you do some fine tuning in reality.
There are also a lot of work which work on making this type of model, this type of algorithm that they use to learn more efficient. Like they can learn from a really few number of demonstration. So this is also a path that are taking the research. I saw some paper from CoRL 2025. So I think, and it's a join what Zakariea said, maybe at a time we are be capable of, with a very few demonstration, to be able to learn something without needing a huge amount of randomization, things like this. But we are not at this point still yet.
Lukas, you have thoughts on this that you wanted to share?
Yeah, so I saw a really interesting video from NVIDIA recently. I don't know the name of the presenter, but he said that we basically need 3 paths. So the simulation, the teleoperation, and then also just using Gen AI to basically dream how the robot could perform some tasks. So I think all of the 3.
Have you guys have any experience with the NVIDIA dreams, the process of so you just recently seen it? Okay. So I recommend you guys go look into that, because that is essentially you are showing synthetic data from a POV of the robot of randomized, feels like dreams for the robot, essentially collecting trajectories and data, but it's all synthetic. So we're kind of pushing that at REVEL as well, because I guess in robotics, we are all kind of on a path here to get to the ChatGPT 3 moment, to where we can say now with kind of works. And then, GPT-4, when it was like, I can actually start building some useful things. And GPT-5, arguably, it's not the best example, but you guys get the point that I'm trying to make, I think, is now we're really actually making applications and whole systems and businesses built around. I just recently saw the model from Google DeepMind, the R1.5, which I think is arguably sort of that similar stepping stone in terms of like maybe like a GPT-1.5, GPT-2. And I think that we're going to see similar trajectory in robotics or physical AI. And have you guys seen Figure making and announcing the partnership with Brookfield? It's basically a portfolio of about 100,000 residences where they're doing something like Zakariea basically talked about, where they're giving people, not sure about VR headsets, but I think they're giving them like GoPros to just record videos from their POV going around their houses and cleaning up, tidying up, cleaning kids' rooms to they call Figure's calling this a project big, and they are basically on the mission to collect as much data as possible to create the biggest pre-training set of data to show the humanoid, like, here's all the possible messes of toys being randomly thrown and plates and dishwasher loading and unloading. And so that was an interesting approach, one that actually hugely and their model Helix that hugely validated something that we're working on in the background. And so loan to where I was going with that is, so imagine we take those videos that you see that were recorded by humans, but what if we could just create those synthetically completely, and instead of having 100,000 homes, we can have 100 million different homes synthetically generated, and we can then take that data to kind of fine tune and train the model. So that in a nutshell is what that's how we're looking at the data bottleneck at REVEL. It's like we have enough information about all of the assets that you interact with in the world, from things you buy in grocery stores and things you buy in hardware stores, anywhere basically. There's enough public data in terms of pictures, videos, training manuals, data itself, to where we can use a lot of different LLMs that are quite powerful, text or generative, to then create a video that, that generative world, that generative physics, to where it appears like it's obeying the laws of physics. It's generative, it's just pixels, but it looks like it got the center of mass of that object quite done well. I don't know if you've seen Genie 3 from Google DeepMind and some of the simulated physics there, the water splashing and stuff. I mean, that to me looks like a jet, the wake that, jet ski would produce on a flat lake, like a solid of a body of water. It's obvious, and the compute of it, the demand on compute for something like that versus calculating all the droplets and all the all the displacements of the water and the physics engine. That's where also cost comes, like the demand for compute. It's like a X difference, or if not more, for something as complicated as particle simulation like water. My background, gentlemen, is, I don't know if you know, but if you looked up some of my stuff on the background and profile, is I come from Hollywood, basically, or the film industry. So VFX, VFX, I would not want to be in a VFX business as of today, because they're definitely going to get heavily disruptive with the generative models and AI, and they're going to have to adopt and onboard all these tools into their pipelines, essentially simulating like the compute to simulate the VFX shot where there's some complex particle scenario happening, and that's not even real physics. It's like it's like just to make it look good in a lot of these engines.
That's the point. Like, how good can you then translate it into reality? Like, how good is it usable for actually training a robot that needs to do stuff in reality? I think that's the point that Luan also made previously.
I guess the answer to that is we will see, but the idea is with the generative process, you could essentially create so many randomized variations where you're kind of creating almost this like every instance of possibility, and then having training, and then just that sheer volume of token, and then fine tuning to where you distill from good or bad, and kind of having having kind of like a loop, like you create a model and then you run it through some agentic system that looks at it and labels it and says, well, that's not good, that's good, that's not good. And so yeah, I really enjoyed the conversation, gentlemen, and again wanted to say thank you so much for participating in the hackathon. I hope you guys are gonna join the next one. I'll hear you, Pascalis. We'll give it more than 2 weeks.
Okay, yeah, that's great.
We're gonna give it a little bit more than 2 weeks for you guys to compete. We'll stay tuned for the details from REVEL and on LinkedIn. Lukas, Pascalis, Lone, Jan, who's not here, Zakariea, and thank you guys so much for participating. Congratulations again. Really enjoyed meeting you. Really enjoyed talking to you guys as well. You guys have any closing statements on your projects, or kind of maybe a little shout out to what you're working on, where you're at, what you're doing, what's next for you, and then kind of we can close it out.
Sure, well, definitely a shout out to Muammar, to LycheeAI. He was actually the reason I joined everything. The huge motivation. Thanks, guys, for organizing it. That's pretty much my closing words.
Yeah.
I hope to get to see you do something in the next one with your pup. I think that would be really cool and fun.
Yeah, we'll see. He's taking a nap now.
All right, Lukas, Lone, Zakariea, all good?
Yeah.
Yeah. I think for the next hackathon, I will try to participate, but it's in November. I have a calendar, a very church calendar, so I will try to build a team with someone else and try to compete like this, because maybe I hope the hackathon will be available in Teams. But yeah, definitely trying to do something else, something maybe more complicated with learning, and try to train my own models to complete the hackathons. And yes, that's pretty precious.
Sounds great. Lukas, what's next for you?
Nothing in mind right now. And I could just repeat what Pascalis said. So thanks to you for organizing it, and Muammar, of course.
Yeah, you're super welcome. Zakariea, when are you
I can
getting off
also
of
only add on
vacation
that.
back to? Oh, okay.
Yeah, thanks for organizing that. I had a lot of fun. It was a great learning experience. Yeah, I would love to participate also in the next hackathon. Maybe I'm gonna buy a Apple Vision Pro so I can also teleoperate the humanoid. But I would be missing some credits, NVIDIA credits for the BREF. It's gonna be
Yeah, I think
really
you
expensive.
won some. I think you won some, and they're part of the prize pool. So I think we'll be sharing all that with you guys shortly.
Let's go.
The Apple Vision Pro and the VR headset. I think it's a great idea. I think we should throw a couple of these into the prize pool for the next one, because you guys all said that you were pretty interested in doing some teleop or some Groot mimic. So we'd love to see that. And yeah, I think those are definitely things that we'd like to throw in, some SO1 arms, or maybe even some other robotics. Like, we want to 10x the prize pools. We've been even talking how cool it would be to put like the UniTree G1 maybe as a prize into the prize pool. Who would like to have a humanoid at home? Gentlemen, yeah, there you go.
Count me in.
Well, you're gonna have to outperform the claw machine. So thank you guys so much. Really appreciate your time jumping in here and making this work, even over the technical difficulties. And Lukas singling out Kamil, just not wanting to hear him talk. Gentlemen, thank you so much. It's been a pleasure.
Thank you.
Hopefully we'll catch you
Likewise.
guys on the next one. Again, thank you guys
Thank you,
so
Brian.
much.
Thanks for
Thank
the
you
Thanks a
very
invitation.
lot.
much. See you. Bye.
See you. Bye.
Bye, guys. Thanks you. Thank you. What is thanks you? All right. Thank you, everybody, for listening, joining in. Everybody hopped off. Kamil was long gone. So, yeah, really enjoy the podcast. Really enjoyed the episode. Really like talking to the contestants. They've really delivered some amazing projects. So stay tuned to the next one. And thank you for listening. Have a great day.